Oops. All right. How's everybody doing today? We are going to be actually not doing a whole lot today because I realized that the whole lenses are actually on a different chapter. So today we're going to be just focusing on your mirrors, and we're going to finish that up, and you guys are going to have a little reading to do about polarized light and that kind of stuff. Okay? So we're going to go ahead and go through, oops, not this. So that's going to be your homework. So your homework is going to be the formative assessment on page 759. So that's for next time. That's for Friday. Okay? And then today, so you got this whole reading to do about polarized light, color. And today we're going to be looking at, if I can get there, the convex lenses. So they're your diverging, not your convex mirrors, your diverging mirrors. Here we go. And let's go ahead and just jump right into that. So before we begin, just shalom, shalom. All right. Good to see everybody there. And for those of you in the chess tournament, how's it going? Hopefully well. I don't know how I got stuck in, are blessed to be in the group with the Bruces. So I got both of the Bruces in my chess group. It's going along pretty well. And I don't know how the other groups are going along. Adam, how's your chess group going along? Anyway, as I wait for the answer, Jason lost his queen to you. Haha, nice. He's done that to me before too. He's not always careful with his queens, so you can get it. He's running. All right, so it's just a matter of time. All right, so today we are going to be looking at mirrors, and I just want to say about the test. So we're gonna have a test. So normally I would have combined this chapter with the next chapter, but because we didn't get a test the last chapter, we just kind of hit spring break and then just moved on. What we're going to do is we're going to have a test that's going to be next week. That's going to be about mirrors. It's going to be a little bit about light, and it's going to be about sound. Okay, so we're thinking about tests for next week, and theoretically we could have it Monday, but I don't know. I don't think I like Monday tests as much. So we're going to go ahead and do the test on Tuesday. I think we should be all ready for that. And I feel like we should do a live stream where we just diagram mirrors and nothing else. Okay, I think a lot of today might be diagramming mirrors, and I can diagram all these ones. If you want me to diagram more, if any diagram bothers you, we can diagram more. And I'm going to give you guys some diagramming review. But basically, we're pretty much done in terms of mirrors. And what we're going to do is we are going to be, you guys are going to have a little reading to do, and then we're going to just do some review. So Friday, Monday is really just review, and then Tuesday for the test. What's the name of this book? What is this book? Good question. I think this is like, let me see where we hit it. I don't know what the name of this book is. I'll figure it out at the end. Does anybody know what the name of this book is? Anyway, it's a pretty common physics book. Anyway, I'll look it up at the end. So if anybody knows, they can chime in here. Let's go ahead and jump right into this, though. So we have a crayon. No, I even forget. I'm so sorry. This whole distance learning thing is getting me kind of confused myself. But where are we? This is 13C, and I assigned 2 to 6, so not number 1, right? For some reason, I didn't like the crayon. No crayon. Let's not do the crayon. So we're going to do numbers 2 through 6 on here, and I don't think I've gone through any of them yet. So basically, we have the entire time to do this because I'm not going to be talking about new material. It's just a little bit of reading on stuff, which I think you'll find fairly easy. Color stuff you've already learned before. I'm sure you guys already know the color stuff. And then a little bit of stuff on polarizing light, which it really isn't too bad. So anyway, physics HMH book. That sounds about right. Yeah, that sounds about right. All right. So number 2, we had convex mirror. Convex mirror, nice. With the focal length and all of these, anytime you get this convex mirror, you're thinking, okay, focal length is going to be negative, right? Negative focal length for a convex mirror. And all of these are convex mirrors, I believe, in this particular homework, right? Number, I just wanted to see if I can fit everything in there. There we go. There we go. All right, number 2. You have a convex mirror. Actually, you know what? The best way to do this is this way. Yeah, so I can do this both here. All right, we got a convex mirror, and the focal length is 0.25 meters, and we can leave everything in meters. We can convert to centimeters, whatever. So I'll just leave it as meters because you guys probably did. Negative 0.25 meters. And it forms a 0.08 meter tall image. So the height of the image is 0.08 meters or 8 centimeters tall of an automobile at a distance of 0.24 meters behind the image. So this is the image height, and then this is the image distance. So this is going to be Q. Is going to be negative 0.24 meters behind the mirror. What is the magnification of the image? So we're thinking, this is a car mirror. It's going to be one of those mirrors where it says images are closer than they appear, right? What is the magnification of the image? So we want to know magnification, and we're probably going to need to calculate P first, then we're going to calculate magnification and all that stuff. So let's go ahead and do that. So once we have this information, we really only need F and Q in order to figure out P, and then we can go back and figure out how big the object is. So this is going to be used to figure out how big the object is. So and notice that these two things are really close together, which tells me that this object, there's something special about this object. It's probably going to be pretty far away because your Q and your F are fairly close together in this case. So let's see if I'm right. Maybe, maybe not. So 1 over P plus 1 over Q equals 1 over F. And I do have my calculator today. That's nice. Let's light this up. All right. So 1 over P. And we're going to calculate 1 over F. So 1 divided by 0.2. 1 divided by negative 0.25. That's this part. Then we're going to subtract 1 over Q from both sides. So we're going to subtract a negative. So I'm really adding, okay? So you can do the subtract a negative, or you can just add 1 over 0.24, right? And then we're going to take the inverse of that to get us P, and that's 6. 6 meters, that is. So P equals 6 meters. All right, are we good with that? 6 meters? Okay, so that's going to be a distance 6 meters away. So that's definitely going to be behind the car some distance, right? So car is going to be only, maybe 3 meters long. And so this is going to be fairly close to your car, about 3 meters behind your car, something like that. Now, once you have this, you can calculate the magnification. Magnification is going to be negative Q over P. So that's going to be a negative value here. And negative and negative is a positive 0.24 meters over P is 6 meters. Meters over meters cancel. And this is going to be fairly small magnification, right? Which we'd expect for a convex mirror where something is, going to appear further away or appear further away than it really is. So we have 0.24 divided by 6, and that gives us 0.04. 0.04, which is fairly small magnification, right? So that's, a lot. So something's about 4% of its normal size. So it's a lot smaller, right? What's the magnification? Where is the car located? We already said the car that other car is 6 meters behind your car. What is its height? So if it appears to be, the image height appears to be 0.08 meters, and we can go ahead and write down the equation. So your magnification is negative Q over P, or your magnification is the object height over the, I'm sorry, have that reversed. It's the image height over the object height, right? And we know what the image height, but we don't know what the object height is, so we can just flip them. So that's going to tell us that the object height is going to be the image height divided by 0.04. Right? We're just going to flip this and this, multiply both sides by the object height, divide both sides by 0.04, and that's going to get us a value of 0.08 divided by 0.04, so that sounds like it's going to be 2, right? So 0.08 divided by 0.04 is going to be 2. Yep. So that should be 2 meters. This is unitless, and the object, or the image height, it has units to it. So this is going to be 2 meters. Height of a car, 2 meters. That seems pretty high for a car. That's like not a car. That's like a truck or something like that. Or some, yeah, what is that? This is, it does say it's a car. Cars are not normally 2 meters high, right? You can think of your own car. That's like, you know, pretty high. That's going to be some, at least we're talking, even a van typically isn't even 2 meters high. Anyway, this is 2 meters. I think that's the correct answer. So there we go. Any questions on the first one? This is number 2. First one in your homework. I'm just going to look up, maybe a pickup. Yeah, that's what I'm thinking. Maybe a pickup. Although it did say, you know, it said car. Car. But I'm guessing it is probably a pickup. Some, you know, that's pretty reasonable for a pickup. Yeah. All right. So moving right along. We have number 3. We got a convex mirror, another convex mirror, obviously. Focal length, and any of these you want me to do a drawing of, I can, but this one is going to be pretty sketch to do a drawing of because this is 2 meters high, and the image is only 0.8 meters. Whenever we have a ridiculous magnification like 0.04, it's going to be really, really hard to do some kind of drawing for something like that. Okay. But let's just go ahead and plug them along, and then any of these other ones that you want me to do drawings of, I will. So, number 3. Convex mirror focal length. Once again, we're thinking convex mirror means our focal length is negative 33 centimeters. Forms an image of a soda bottle at a distance of 19 centimeters behind the mirror. So that is going to be a Q. I wonder why it keeps on giving us Q rather than P. But anyway, so we have the image, it's 19 centimeters behind, so it's negative 19 centimeters. The trickiest thing about these things is just, is it negative or positive? And it says, well, we know convex mirror is negative, and we know it says behind the mirror. As soon as you see behind the mirror, you're thinking, okay, that's going to be negative there, okay? Plus is convex mirror, so it's pretty much always negative. If the height of the image is this, very similar problem, right? Height of the image is 7 centimeters. Okay, same thing. Where's the object located? How tall is it? Magnification. Obviously, you need the magnification before you figure out how tall it is. And is it real or virtual? We can go ahead and even answer that right away. If this is negative, we already know this is virtual. Or is a convex mirror? It's going to be virtual. And is the image going to be inverted or upright? We're going to say right away, this thing is going to be upright. Why? Because it's a convex mirror and this thing is virtual. And those go together. It's going to be virtual and upright. So we can literally answer those before we even do any math or before we even draw the thing. Okay? And we'll see if we're right. You know, if we're wrong, we can go back and adjust it, but we should be right. All right? So, all of these are virtual and upright images. Yeah. All of these, if they're convex mirrors, they're all going to be virtual. They're all going to be upright. It's pretty much a given for all of your convex mirrors. All right. So 1 over P plus 1 over Q equals 1 over F. And we're solving for P once again. So that's going to be a 1 over negative 33 minus let's just go plus, minus a negative 1 over 19, so plus 1 over 19. That's going to get me a positive number. Take the inverse of that, and that's positive. Your one thing that's always positive, and that's your value for P, right? Because your P can't be negative. You can't have an object behind a mirror. Only an image can be behind the mirror. So that's 44.8. P is 44.8, which means that your magnification then, negative Q over P, and that's going to be negative, so you have 19 centimeters, this is centimeters, over 44.8 centimeters. 19 divided by that gives us a magnification of 0.42. 0.424. Okay, and that number is unitless. Don't give magnification any units. That would be incorrect. And then if we have an image height, we can now calculate, I think it asks us how tall it is. Okay, so if we want to know what the object height is, once again, your object height is going to be your image height divided by, can you guys see this? Let me move this up a bit. It's going to be your image height divided by magnification. We figured that out last time, right? Because the magnification equals your image height over object height. And we can literally just take those two numbers and flip them. So that is therefore 7 centimeters over 0.424. Let's do the math. 7 divided by that. And it gets us 16.5. Nice. Nice whole number. 16.5. Well, not whole number, but you know, you get what I'm saying. 16.5 centimeters high. And we're going to go ahead and do now the image diagram. The mirror diagram. Okay? And I don't know why, man, this looks so red-ish. I don't know why it looks so red. It's just weird. So what we're going to do is break out your straight edge. Hopefully you guys should all have rulers at home. And the first thing you're going to always do for your mirror drawing, lens drawing, or whatever kind of drawing, your ray diagram, whatever, is draw your principal axis. You don't have to make it this long, but make sure you draw your principal axis, and then you can get some kind of an arc here for your mirror. All right, and then you can just put that in the center somewhere. Right? If we were doing and I know this is terrible actually because it looks like it's curving more at the top than is the bottom. So that's terrible, but it's going to work. All right. So if I were doing a concave mirror, I would be on this side, but because I'm doing a convex mirror, I'm going to be on this side for my object. I write a tree for all objects because I like trees, right? And trees are nice. And so before I even do that, I'm going to find out, all right, my F value, F is 33, and where's my P value is, where's my P? P is 44, so P is kind of bigger. The book image has it the other way. Yeah, and you can do it the other way. So this is going to be a variety. You can have it this way or you can have it that way. Oops, I did not mean to draw that little thing. Anyway, so sorry about that. You can have it going this way or you can have it that way. But if it's a convex mirror, your object is going to be on this side it's going to be on the side where it's curving away from you. Okay? So it doesn't matter left or right for that one. All right? So we have F is negative 33, and let's just go ahead and make this F. That's going to be 33, and we can kind of, you know what? Actually, I've been estimating. We can actually kind of measure it. I don't know, what is that? That's like 2 points. It's like right there. All right, and then here's going to be my center. Get myself a little bit more accuracy here. And then that we said that's 33, and then 44 is going to be, oh man. So if this is 33, and then 44 is about like a third more. I'm going to say like right there. That seems about right. Just estimating, okay? So I'm going to go ahead and draw this tree. Okay. once you get your tree drawn, or your car, crayon, or whatever you want to draw, then what we're going to do is do our ray diagrams. I'm going to go parallel in for my first one. Oops. Parallel in, and then is going to reflect through the focal point, which is right here. That's my focal point. When it reflects through the focal point, it's going to bounce out this way, but you're going to notice that you're not going to form an image over that way. The image is going to be on this side. So I'm going to put my dotted lines. This is my, there is no light here, but that's the direction of the reflected ray. So incoming light goes this way, hits the mirror, and bounces up, bounces away, right? And then this is along that reflected beam. All right, I'm going to choose my other one as the center, just like this. Let's see. Okay, are we back? I think we're back. Yep, I think we're back. Okay, sorry about that, guys. So I think we got the first ray in before we started having some lagging there. Anyway, so let me just review. First one was parallel in, right? And then it's going to reflect through the focal point, but it can't actually go through the focal point because the focal point is on the other side of the mirror. So it's going to reflect out that way, and we do our dotted line in towards. So this is the reflected beam, and this is where the light actually is, and this is in La La Land. This is virtual light. There is no light here. It's just virtual light. This is where, you know, the light would be if this was not La La Land. Okay. Now, so we have light coming in here through the center. So when it comes through the center, it's going to hit the mirror, and then it's going to bounce out through the center, in and out. Right, but we have to go because there's no image on the real side of the mirror. Oops. And I'm having a little trouble with my dotted lines. So there's no light on the virtual side. These reflected beams do not cross on this side. So it comes in like this and then goes out like that. And these beams never cross, the reflected beams never cross on the real side. They only cross on the virtual side. And so where they cross on the virtual side, that is where the image is. And I'm going to go ahead and draw my new tree like this. Because they cross above this principal axis, we know that it's upright. And because they're down this hall, we know that it's small. In fact, it looks like it's less than half. Indeed, the magnification is 0.4, right? So it should be less than half the size. What about the value for Q? -19? That kind of makes sense, right? So we said this is 33, so this is around 20. You know, it's not exact. Okay, so that looks pretty good for a ray diagram or a mirror diagram for this. Any questions? So sorry, guys, about that. So the book has the image the other way, and you could literally do this whole thing flipped the other way, which is perfectly acceptable. I just decided to put the object here and the mirror going this way, but you could flip it either way is perfectly fine. That doesn't matter. What matters is that it looks something like this. Okay. Now, let's go on to number 4. Number 4, another convex mirror question. So in the initial question for P, one of the values always has to be positive in the calculator. Yeah, I think I know what you're saying, and I think the answer is yes, because if you mean this, when you're initially calculating P here, well, first of all, P must be positive, and secondly, when you're calculating P, both of these numbers are going to be negative, right? Your F is going to be negative, your Q is going to be negative, but what you're going to do is you're going to bring your 1 over Q to this side, and when you bring it to this side, it's going to end up being positive, and because your Q is pretty much, I'm pretty sure it's always going to be less than F, that's going to make 1 over F minus 1 over Q turn into always a positive number, okay? So when you bring it over to this side, it's going to end up being positive because the negative of a negative is a positive. Okay? All right. And I think we're going to find that also in number 4. So let's go ahead and just jump right into number 4. Okay. They can't, exactly. They can't both be negative for a convex mirror. For a concave mirror, they can both be positive, but your P, no matter what, your P is always positive. All right, number 4, convex mirror, radius. This time we're given a radius, and because it's convex, once again, we're going to just call this a negative value. So this is negative 0.55 meters, and your focal length is simply going to be half that, which is great. I don't know. Sorry, this is just coming off again. Here it's placed above an aisle in the store, so it's one of those anti-theft mirror kind of things. Determine the image distance and magnification of a customer lying on the floor 3.1 meters below the mirror. Okay, below the mirror. I'm guessing that's going to be our value for P, right? 3.1. Although the word below is a little bit weird. It should be away from the mirror, I would think. 3.1 meters, because they can't be 3.1 meters unless this is a really, really tall building, right? 3.1 meters, we're talking 10 feet above a person, and a person already is a meter tall, or a couple meters tall. So that's ridiculous. So that must be your p-value. Is the image virtual or real? Is the image inverted or upright? We can already say, if it's a convex mirror, the image is going to be virtual and it's going to be upright. We already know the answer to those, okay? So, yeah, we already know. Let's go ahead and say, so virtual and upright, simply because it's convex. But let's go ahead and calculate the value for Q now. So we have 1 over P plus 1 over Q equals 1 over F. Now we have same type of calculation, just we're calculating the other one this time. We're figuring out where the image is, which is more fun, I think, the way it should be. So 1 divided by a negative 0.275, right? And then we're going to subtract from that 1 over P. And this time P is positive, so this is going to be minus 1 over 3.1. All right. And then we want to get the inverse of that to get us Q. And as we should, we're going to get a negative number for Q. So Q is going to be equal to negative 0.252, or we'll just leave it at negative 0.25. All right, or I'll just write 253 meters. And our magnification is negative Q over P. So your magnification is going to be this divided by 3.1, but we have to take the negative of it, so the negative is going to go away. So we got, oh man, that's a really small magnification once again, 0.0815, 0.0815. You should really only have 2 significant figures, but I'm just going to give an extra one because I'm getting these 5s here. And do we want to know, does it tell us how big the thing is? No, I don't think we need any of that. All right, I think we're just good. We can go ahead and do the diagram. Does it say to do it doesn't even say to do a diagram. I got a ridiculously small magnification. I'm not even going to do the diagram. I don't think we have to, right? Yeah. Yeah, let's just go on to the number 5. Oh, number 5. This is an ornament. That's nice. Let's do number... All right, ornament. Oops. Ornament number 5 is 6 centimeter in diameter. And so now we're getting the diameter, which is just going to make this thing a little bit, so the diameter is 6 centimeters. That means that the radius is going to be of this thing is going to be 3 centimeters, but we're also talking about, because this is a glass ornament, we know that this is going to be acting like a convex mirror, so this is going to be a negative 3 centimeters. So our focal length is actually going to be a negative 1.5 centimeters, right? So that's our focal length. And the object is, we have an object that is 10.5 centimeters away. We want to know where it is, magnification, all that kind of stuff. Maybe we can do a, let's see how this works out. As long as the magnification is not too extreme, we'll go ahead and do a drawing for this one. All right, so we have 1 over P plus 1 over Q equals 1 over F, and we have an F of negative 1.5. So that's going to be 1 divided by negative 1.5 for F, minus, we have a value of P of 10.5, so minus 1 divided by 10.5. And that gets us a negative value there. Take the inverse of that, and it gets us negative 1.3, which is interesting. This is very interesting, because that means the image distance, that doesn't seem right. That means the image distance is, no, that's right, that's right. This is centimeters. Units are centimeters. As long as that is less than this 1.5, then we're good. The absolute value of this must be less than that. And so we're good. So Q is a negative 1.31 centimeters. And so it's very far into the ornament itself. And that means your magnification is going to be what? It's going to be negative Q over P. So this divided by 10.5 centimeters away, which is negative 1.125. So negative and negative, so that's going to be a positive 0.125. So once again, we're thinking this is going to be upright and virtual. Okay? All right, any questions so far? They can't both be negative. Yes, they can't. I think I already answered that one. Should we do this drawing? Should we do any of these drawings? Let's do a drawing for this. Yeah. Let's go ahead and just do a drawing for one of these. This one's pretty small, but I think we can handle it. And we'll just do it over here. Okay? All right. And in this case, I'm going to go ahead and do my mirror this way. And your object in this case might actually be a tree, although 10.5 centimeters away, I don't know. The tree's probably closer than that. But we have a radius of 3 centimeters, so pretty small. And this is, I probably should have made this even more curved, but let's go ahead and make it. So this is, we're going to make that 3 centimeters. And the object, oh wait, no. The focal length is 1.5, so we got to make it even smaller. Okay, so this is going to be 3. This is going to be your 1.5. That's your focal length. This is your center. And then if that's 3, then your object is super far away. So we'll just mark this. That's 3. So 3, 6, 9, and then a little bit further. So like way out here. That's going to be your object, way out here. Nice big Christmas tree, and then you got your ornament. So when you're doing this, there's a number of different ways we could do it, right? We could do it first focal length in and then parallel out. Let's just have a little variety and let's do that one, okay? Let's do focal length in, parallel out. And this is going to be a bit tricky. Of course, I could do parallel in and then focal length out, but I'm going to try this time. We're going to do focal length in. So light coming in, focal length in, and then way down here is going to go parallel out. So it's going to come out like this. But we're going to have, oh man, you just won't even be able to draw this. It's going to be so small. But parallel in, I'm sorry, focal length in, parallel out, and then it's going to extend out this way. And then you can do the same thing for the center. All right, center in, center out. Just like this. Center in, center out, and then it's going to extend this way. Okay? And when it does that, we're going to notice that this image is going to be, oh, this is terrible drawing. This image should have crossed up a little bit further. You can see when the magnification is so much off, these things get to be pretty far off. But this, I'm seeing them cross right around where the focal point is. Let me see, and we have a focal length of 1.5 and an image distance of 1.3, and they're crossing right around the same place. And so I'm getting this little tiny thing. I can't even draw it, it's so small. Okay, that's the problem. When you get these really small magnifications, you end up with something like that, where they cross and you can't even draw the image because they're crossing in and it's so small. All right, that's kind of the problem with these. All right, number 6. Keep in mind, on the test, I will not give you something with such a small magnification for you to draw. That would be pretty difficult to draw. Number 6, last one here, we have a candle. It's 49 centimeters in front of a convex spherical mirror, has a focal length of, so let's go ahead and do this, 49, so that's 49 is your P, 49 centimeters in front of a convex spherical mirror, focal length of 35 centimeters, so focal length is 35 centimeters, but it's convex, so we know it's got to be negative. What are the image distance and magnifications? So we are solving for Q and M. Once again, 1 over P plus 1 over Q equals 1 over F. So your F is negative 35. So 1 divided by negative 35. And we want to subtract 1 over P from both sides. So that's going to be minus 1 over 49. Take the inverse of that, and we're going to get negative 20.4 for Q. Q equals, keep on doing this, negative 20.4 centimeters. That's a pretty reasonable thing to draw. No problems at all with that because we're not going to have a huge magnification. Let's go ahead and calculate what is the magnification. Negative Q over P. So it's this number divided by 49, and the negative of that, or 0.417, 0.42, 0.417. Okay. Is the image virtual or real? Of course, this thing is going to be virtual. All of your convex mirror images are virtual, and it's going to be upright too. If you didn't remember that for your convex mirrors, you can remember it this way, right? This is positive. Because that's positive, that means this is upright. Okay? Your Q value is negative. So positive M is upright. Negative Q is virtual. All right, so those positives and negatives will always tell you about what kind of image you're dealing with, virtual or real, upright or inverted. All right, let's do this. This one should be a little bit easier than the last one. I probably shouldn't even try the last one, but I did. Here we go. And we could put this thing on either side that we want to. Let's go ahead and put this time like this. We have a focal length of -35 and a P of 49. It's not quite 1.5 times that. It's almost 1.5 times that. So 50 is almost 1.5 times that. So we have an F of, so this is going to be our F. Right, and then that means our object is going to be like right about like that. If this is F, then our center is right here. Okay, we're going to draw our tree. And there we go. There's our object. There is our focal point. There is our center. Those are approximate in terms of how they look, right? Once again, we have a convex mirror. And so what I want to do is I want to do parallel in. Once it hits the mirror, it's going to bounce out. And it's going to go through the focal point, but the light won't be able to actually travel there. And so this is the extension of where the light goes. It's actually going to go out this way. It's going to go through the center and back through the center, just like this. Through the center, and then this is an extension of the reflected light. So in this way, out that way too. Where they cross, that is where your image is, right here. My image tree got a little bent. All right, does that make sense? Yeah, that makes a lot of sense, right? So we have, once again, we have a smaller image. This looks like a little bit less than half of your original object, right? So this is how big your object is, and it's a little bit less than half of that size, which makes sense, right? 0.42 magnification, and we have so this is, what is that? That's 35, and this is 20, more or less, okay? So that is how to do these. You'll notice that pretty much all these are the same. They're only really, really tricky when you have very small magnifications, okay? If we were to try this one, it would be virtually impossible. I thought I could maybe get away with doing a magnification of 0.125, but you could see that this is an utter epic fail here. And so once you get to less than, let's say, 0.25, your magnification, your image gets so small that unless you're doing like a full page, it's pretty hard to do a good drawing of it. All right, so that's it. That's all the homework for today. I think, look, we've gone over a little bit. Sorry about that. And I think we're going to be done for today. So there's nothing new that I want to teach you guys. You guys have some reading to do in the book, and that's about it. And then we're just going to end there. So on Friday, I'm going to go ahead and give you guys a review. So we're going to start reviewing, and we're going to do a test. Now, remember, the test is going to cover both these mirrors and the sound stuff that we were doing previously. The sound stuff, so we're talking about decibels, we're talking about sound intensity. All right, and then we're going to wait to do lenses until after the test. So we're going to shoot for a test on Tuesday, and I think that's pretty much it. So we have a little bit of a review that we can do on Friday and Monday, and we'll just take it easy. I think we're good. All right, any questions, just feel free to ask. I'm not seeing too many questions in the notes here. Anything at all? Questions? Homework. So I'm sorry, I haven't uploaded the homework yet. I'm going to write it down like literally in the next 5 minutes. I'm going to put the homework down. The homework is going to be the formative assessment. I forget which page it's on. I'm going to go ahead. I think I said at the very, very beginning of the class today, but it's going to be the formative assessment. It's going to be a little bit on light in general, colors, and something that's really cool, the polarization of light. I think polarization is something important, but the other stuff is all kind of should be old hat to you guys. Page 759, that sounds about right. So the page 759 formative assessment, and that's it. and I'm going to go look it up, verify. So the reading and just the formative assessment. I think you'll find formative assessment pretty easy. Okay, it shouldn't be hard. All right. Okay, cool. So I'm going to go ahead and end it there. And then, oh, and Hannah, tell your brother he's got to hurry up and move. He's been taking literally like the full 3 days per move here. I want him to hurry up. All right, cool. See you guys.